We're on Chapter 2 now, Lesson 9, again with a textbook using Larson. We're on 2.1, Quadratic Functions. Okay, what you're supposed to know about quadratic functions, what you're going to learn in 2.1. You're going to learn how to analyze graphs of quadratic functions, write quadratic functions in standard form, and use the results to sketch graphs of functions. Find the minimum and maximum values of quadratic functions and real-life applications. All right, so let's break down some words. When it says analyze graphs, what it means is that you need to, on your graphs, you need to note the max and min when you graph it. You need to pay attention to what the domain and range are. So when you graph it, the max and the mins, you need to have it on the graph. You need to have the X Intercepts on the graph. And you need to have the general shape. I would make sure, just to make sure that your graph that you graph on your calculator looks like the picture that you're drawing on your assessment. I mean, they give you everything underneath the table. There's no reason not to take the time to go under the table and put those points in there. All right, then another thing on the graph you're looking at is where it's increasing and decreasing. Again, when it's increasing, the slope's going up. When it's decreasing, the slope is going down. All right, and then we're going to talk about standard form in a little bit here for a quadratic function. And we are going to use real-life applications, or again, they like to call that now modeling, or really the root word is story problems. So you're going to maybe minimize the amount of packaging that is used so that you can save the company money packing something. So minimize packaging or maybe maximize profits. All right, so here's a picture, quadratic function, which we've done before. The parent function of it is f of x equals x squared. The domain, remember domain are the x values, where it goes left to right. Where it goes left to right, it's going forever to the right and forever to the left. The range on the parent function starts at 0. Again, the range is the y value, and the y-axis goes up and down. And the y value here starts at 0, 0. So the y is 0. And then it goes up from there. So from 0 to infinity, and it's got a bracket on it because it's included. And it, again, parentheses around the infinity all the time because parentheses mean it's open and it's not closed. When you have a bracket like we did on the 0, that means that's the last point and it's closed there. That's the last point and it's included. It has one intercept on the parent function, 0, 0. It's increasing. All right, so let's talk about increasing and decreasing again. Again, going in from the left to the right. When we come in from the left, we are going down the hill on the roller coaster. It's going down, so from negative infinity to x being 0, it's going down or it's decreasing. And then from 0 to infinity, it's increasing, or it has a positive slope. So it had a negative slope coming in, and then it turned and it had a positive slope. It's an even function. Remember, even means that it's symmetric to the y-axis. So it folds over the y-axis like a butterfly. The axis of symmetry is x equal to 0, and it's got a relative minimum at the vertex 0, 0. I mean, there's no other point lower than that one. On the next page, I'd like us to identify the x-intercepts of the quadratic function, describe the graph of the quadratic function, identify the vertex and the x-intercepts, use graphing to verify your results. Okay, even though really we need to talk about what the standard form of it is. The standard form of a quadratic equation is f of x equals a times x minus h squared plus k, where hk is the vertex. All right, so we'll write that down here on the next page. We want to get this in standard form. F of x equals a times x minus h squared plus k, where hk is the vertex. All right, so we get this in standard form. So we get to do our favorite. We get to complete the square on it because this has a completed square on it. So we need to complete the square on it to find out where the vertex is at. All right, so completing the square on it, again, what you want to do is isolate the x's because we're completing the squares on the x's. And you don't want to have a coefficient in front of the x squared. You want that to be the number 1, which it currently is. And then what you do is you take half of the x value. Half of the x value would be 5, and you square it. So I've added 5 squared to the equation, which changes it. And we don't want to change the equation, so we're also going to subtract it from it. So in essence, we've done nothing to it at all. Nothing at all. Again, step 1, you don't want the x squared to have a coefficient at all. The coefficient of it needs to be 1. So coefficient is equal to 1. And then on step 2, you take half of the coefficient of x, and then you square it, add it to it, and you subtract it. So you plus and you minus the square of it. So anyway, that now is equal to x plus 5 times x plus 5. The middle term is 5x, the outer term is 5x, it adds the 10x. So that is x plus 5 squared. And then 14 minus 25 gives you negative 11. So using the standard form here, the x is negative 5, because you're going to have to do the opposite. When you pull it out, it's negative h. So to make that minus h, it has to be the opposite, or negative 5. So the vertex is at negative 5, comma, negative 11. All right, the actual question wanted to know what the intercepts were. Also, it says identify the vertex. So I did that. And the x intercepts. So the x intercepts are where y is equal to 0. So when is y equal to 0? So we're going to make 0 equal y. So you could solve that either now by factoring or doing the quadratic equation. And it doesn't factor. If you try to factor it, it doesn't factor. So we're going to have to use the quadratic equation, which again is negative b plus or minus radical b squared minus 4ac over 2a. So negative b plus or minus b squared minus 4 times a times c over 2 times a. All right, so when you clean that all up, underneath here, 100 minus 4 times 14, you're going to get 44. And the square root of 44, when you clean it up, is equal to, it is equal to 4 times 11. So that is plus or minus 2 radical 11 over 2. So when you divide those both by 2, you get negative 5 plus or minus radical 11. So those are the x-intercepts. So let's see, they wanted the vertex, the x-intercepts, and then they want you to graph it to verify your results. All right, so again, turn the calculator on, go to y equals. I got plot on that. I want to unhighlight that. All right, so x squared plus 10x plus 14, graph. Oh, I knew it'd probably be a mess. All right, so I got to go to zoom. I got to go down to standard. Now my screen looks pretty. So you can see the vertex is down there at negative 5, negative 11. So it's just off the screen because the standard screen on a calculator is 10 by 10. Goes out 10 each way. So it's just outside of it. And again, if you had a piece of graph paper and you had to graph it, don't forget to go to the table and put some of those points on it that you can. All those are graphable. You might want to, I'd count by 2s on it when you graph it. That way it'll fit on your graph pretty. All right, so the next one. Same thing, we need to find the vertex. So we're going to do that trick again on it. We're going to complete the square. I'm going to isolate my x squareds, my x's. You want to get the x's by themselves. So I'm going to move the minus 4 outside, and it was minus a minus 4. So taking it out, it becomes a plus 4. And so the coefficient right now on my x squared is 1. So now I need to take half of the number in front of x, so half of that is 3 over 2, square it. And so currently, because of the minus out front, currently I've put on a negative 3 over 2 squared. To doing the opposite, actually I need to add it again, so 3 over 2 squared. So inside there, I have x plus 3 over 2 squared. That's the square completed. That's the number that I'm squaring, so that makes the completed square. And then 4 plus 9/4. When you square that, it makes 9/4. So when you add those together, you get 25 over 4. So the vertex on this one is negative 3 over 2 and positive 25 over 4. And again, they wanted the x intercepts. So we're going to want to know when y is equal to 0. So to find the x intercepts again, you want to set y equal to 0. So setting y equal to 0, that gives us negative x squared minus 3x plus 4. Or if you want to multiply across by negative 1, so that gives you x squared plus 3x minus 4. And that actually factors. It factors into a plus 4 and a minus 1. So that makes x equal to negative 4 or x equal to positive 1. So those are the x-intercepts, negative 4 and positive 1. And the shape of the graph, because the negative in front of it, it's going to flip it upside down. So it's going downward. This one was going upward. Nothing else really too big to note. The big one is the negative out front. It made it go downward. All right, so graphing that, we got negative x squared plus 3x there you go. All right, so it's going downward, and it's got that vertex, a negative 1/2, 6 1/4. So negative 1/2, 6 1/4. And again, you could check that. It's a max. It's the highest point on it. So second, calculate the max, which will give you the vertex. So going to the left, if you want to check your work, hit enter. Go to the right, hit enter, and enter again. And we get negative 1.5 and 6.25, which is what 25/4 are. Okay, next one. Same idea. We want to isolate the x squareds. So I'm going to pull the negative 4 out. So that makes x squared plus 6x, and then still minus the 41. But I don't have a coefficient now in front of my x squared, which is what I wanted. So again, take half of what's in front of the x, which is 6. So that makes 3 squared. And then we added 3 squared, but also times negative 4. So actually we put a negative 4 times a positive 9. So we need to do the opposite of that to eliminate it. So I'm going to do plus 4 times 3 squared. So the completed square over here is negative 4 times x plus 3 squared, and then negative 41 plus 4 times 9, or 36, makes a minus 5. So the vertex is at negative 3, negative 5. And then going back up here, if you're going to try to find the x-intercepts, I got to tell you, I'll spoil alert, it doesn't factor. So to save time, I'm just going to tell you, you need to use the quadratic formula on it. So do the quadratic formula on it. So 0 equal to negative 4x squared plus 24x minus 41. So when you do the quadratic formula on it, you're going to have negative 24 plus or minus radical 24 squared minus 4 times negative 4 times negative 41. I'm so out of space, I should grab another piece of paper. And over 2 times a, or 2 times negative 4. I'll get another piece of paper. That's just crazy. All right. So underneath this thing now we have negative 24 plus or minus 24 squared minus 4 times negative 4 times negative 41. When you clean all that up, you're going to get the square root of negative 80. So since you got the square root of a negative number, that means it doesn't have any x-intercepts. So there are no x-intercepts. Because it's got an imaginary number underneath the radical. All right, and again, you could have graphed it. So we talked about this already on the other page, the standard form for quadratic formula. All right, so down here it says write the equation of a parabola in standard form. It has the indicated vertex and whose graph passes through the given point, and use a graphing utility to verify it. So again, we're going to start with that formula. f of x equals a times x minus h squared plus k. So the vertex, we have h and k, and we got the point x, y. I don't know. Do they want us to do much with that? Let me look here. We want to find what a is. We want to know what the a value is. So we are going to do it. So what I tell people is this is like, I compare it to the slope-intercept form, which you're very familiar with. We're going to suppose land. It's y equals mx plus b. So remember, when you're trying to find the equation of a line, you want m and you want b, and you can have x and y are an infinite number of points. They can be any point you want. So they gave us a vertex, which there's only one vertex. There's not an infinite number of vertexes. There's one. But this point is one of many. And the a value is also specific, just like the m value is. So we're going to try to find the a value. We've got the h, the k, but we don't have the a. So we're going to use the 1 point, kind of like we used the 1 point to find the b value. We're going to use this 1 point to find the a value. So y, which is -7, equals a times x, and x is 1, minus h, which is 4, squared, plus k, which is 1. So you get -7 equals, let's see, -3 squared, which is 9a, plus 1. Oh, shoot. I did it wrong. So anyway, let's do it again. So we've got x is 6. That's what I did wrong. Minus h, which is 4. And then plus k, and k is 1. All right, that's better. All right, so, and I didn't plug the y in. The y was -7. So then we have -7 equals a. 6 minus 4 is -2 squared, which is 4. Move the 1 over, which makes it -8. Divide by 4, and you got -2 is a. All right, so we've got the a value, we've got the k value, so we just take all that, plug it into the formula that we had, and we're done. Just like we needed to find m and b, we plugged them in, and then we're done with the lines. We just plug those in, and we're done. So f of x equals a, which is -2, times x minus h, which was 4, squared, and then plus k, which is 1. All right, so that's the answer to the whole thing. All right, doing it again here. So we got, again, f of x equals a times x minus h squared plus k. This is h, this is k, this is a point somewhere on it, x, y. Again, it's an infinite number of points. We're trying to find the a value. So f of x, the y value is -17 over 16. A we're trying to find. X is 0. Minus h, which is -1/4, so it makes plus 1/4. And then plus k, and it was a -1, so -1. So -17/16 equals 1/4 squared, which is 1/16, minus 1. So cleaning that up now, cleaning it up is where things go wrong for some of us. So we got to move the -1 to the other side, so that's plus 1, or plus 16 over 16. So that makes -1/16 equals 1/16 a. So dividing by that, it's the same number, so you get -1. So a equals -1. And again, you can put that in your calculator if you need to. So then we've got f of x equals -x plus 1/4 squared minus 1. And we're all done. I plugged the h and the k into the formula, and I put the a there, which was -1. Last one here. We got a story problem. Consider the function f of x equals ax squared plus bx plus c with this vertex. This is a formula you really do want to know. You want to memorize this. The vertex of any quadratic equation is -b over 2a, and then to find the y value, you plug the x back in. So you do f of -b over 2a. And then if a is greater than 0, the graph looks like this, and so you have a minimum value. If a is less than 0, well then it flips upside down, which gives you a maximum value on the graph. All right, so we have a physics problem. It says the path of a diver is approximated by y equals -4/9 x squared. So there's a little negative there. You can hardly see it, but it's negative. Let me double check and make sure I'm right here on a better copy. I don't know. I think it's negative. We're going to stick with that. All right, so negative 4/9 x squared plus 24/9 x plus 12, where y is the height in feet and x is a horizontal distance in feet from the end of the diving board. What is the maximum height? So negative b over 2a. So negative b, they want the max height. So yes, that's going to have to be negative if to have a max. It's going upside down, so we have a maximum point. So negative b over 2a. The b here is 24/9. So that's negative 24/9 over 2 times a, which is negative 4/9. So 24/9 and divided by, multiply straight across, that makes negative 8/9. So, whoa, you couldn't see that. That's so sad. Okay, so again, b is 24/9, and then a was negative 4/9. So I did 2 times negative 4/9, which makes negative 8/9. So then we have 24/9 times 9/8. Because when you divide, remember you flip it over and multiply. So that then makes, canceling that out, that makes negative 3 for x. And then what you'd have to do is plug in that 3. Well, actually made a positive. I lost my negative there. So it made a positive 3 because those were both negative. Anyway, so you take your 3 then and you plug it back into the original equation up here to find what the y value is when you plug the 3 in. So y equals negative 4/9 times 3 squared plus 24/9 times 3, and then plus 12. And when you do the whole thing on your calculator, you're going to get 16 feet. So the answer here is 16 feet. All right, now YouTube cuts me off after 22 minutes, so I tried to get that in really quick, so my apologies. You guys, I'll see you for the next lesson.